Hello and welcome to Empowered Learning. This is the second video in the Basic Matrix Operations series. And so I wanted to continue on with the next set of questions. And so this particular problem asks if we have a matrix equation x minus a is equal to b, we wanted to solve that for x if we know what a is. And also if we know what b is. So here, if we look at this, we know that to solve for x, wrote that wrong, so let's come here and say that's minus, and then that's equal. Then here to solve for x, we just need to add a to both sides, which means now we have a plus b. So now that means for us that when we write down our matrix, we're just adding these two together here. Of course, the result, just add 3 minus 9 is a negative 6. Negative 9 plus 9 is 0. Negative 5 plus 5 is 0. 5 plus 0 is 5. And negative 9 plus 0 is a negative 9. And 7 plus 8 is 15. So that is what the resulting matrix X would be. So let's go ahead and type it in. That's also a 3 by 2. So we got negative 6, 0, 0, 5, negative 9, and 15. All right, moving on to the next question. So we want to be able to multiply a times b and b times a, these matrices. And so, of course, we know in looking at this, the very first thing we realize is that a times b and b times a is not necessarily going to be commutative. Okay? And so we're not expecting to have the same answers there. However, since both of these are 2 by 2 matrices, we will get a result for both of them. Okay, so I'll go ahead and make some more room here, and then we will come here and actually multiply a times b and then b times a to see our results. All right, so we got everything set up here, and we have our matrix A, our matrix B, and so now if we're going to multiply them, remember we do row of first by column of second. So row of first by column of second. So here, we're first going to multiply 9 times a negative 9, which will give us negative 81, plus 5 times 4, which gives us 20. So that's what go into the first part. Next, we say 9 times 4, which is 36, plus 5 times negative 6, which is a negative 30. So remember, we are doing row 1, column 1 in the first place, row 1, column 2 for the next space. So now we drop down at row 2. Row 2, column 1 gives us this area here, and row 2, column 2 gives us this particular number there. So negative 5 times negative 9 is a positive 45, plus 6 times 4 is 24. And then, of course, negative 5 times a positive 4 is a negative 20. And then that's plus 6 times negative 6, which is a negative 36. And, of course, now all we need to do is add everything up, and we'll have our answer here. So negative 81 minus 20, that's a negative 61. 36 plus a negative 30 is a positive 6. 45 plus 24 is going to give us 69. And negative 20 plus a negative 36 is a negative 56. And that should be what our resulting matrix of A times B is. So this would be a 2 by 2, negative 61, 6, 69, and minus 56. And let's see, did we copy something wrong again? So nope, we got that. Yes, we did. And I didn't copy it right down here. So let me go and fix that. So that should be a negative 6 there. And that's going to affect everything that I've done in row 2. So row 2, column 1, we need to do that again. Yep, so let's go ahead and do that over again. And let's make that, okay. So let's try this again. So negative 5 times a negative 9 is a positive 45. And negative 6 times a positive 4 is a negative 24. And negative 5 times positive 4 is a negative 20. Oops. Let's get rid of that. Negative 20. And then negative 6 times a negative 6 is a positive 36. So now we have a little different story here. So here if we have 45 minus 24, and let's see, that's going to be, we know that 44 is going to be 20, so that should be 21, yeah. And of course, negative 20 plus 36 is a positive 16. So let's go and change our last two answers here to 21 and 16. See if it likes, oops, 16, like that. All right, so now we need to go ahead and switch everything and now do B times A. So I'll rearrange this and then make some more room, and then we'll multiply that together. All right, so now we want to multiply B times A. And again, we're expecting to get a different answer here because we know that multiplication is not commutative. So when we do this, of course, row by column. So we'll take negative 9 times 9, which gives us a negative 81, plus 4 times negative 5 gives us a negative 20. So that's for element A11. So now we have row 1, column 2. So negative 9 times 5 is a negative 45, plus 4 times a negative 6 is a negative 24. So now for the next, we have 4 times 9 is 36, plus negative 6 times negative 5 is a positive 30. And then we have negative 4 times 5 is 20. And then plus negative 6 times negative 6 is positive 36. And so if we put this together here, let's make sure that we copied everything right. Okay. So now negative 81 plus a negative 20 is just going to be a negative 101, and negative 45 plus negative 24 is just a negative 69. 36 plus 30 is 66, and 20 plus 36 is 56. So we should be able to type that in and barring that we did not copy anything wrong, we should be good to go. So -101, -69, 56 there, and 66 there. All right, so let's move on to the next question. So now for this one, we want to multiply A times B and B times A again. And so, of course, this is testing to see, do we know what the outcomes are going to be whenever we have our inner dimensions matching. So I'll clear out this and then we'll start to work on this example. All right, so next we have our matrix A and matrix B. So I've written that out. And so we've also written the order or the dimensions of the matrices as well. And for A times B, we see that the result here should be a 1-by-1 matrix, or just a single number, because of course we know that the inner dimensions have to match, and our resulting matrix would be whatever the outside dimensions are. So that would be a 1-by-1 here. So whenever we do this, we just say 2 times 3, which is 6, plus 3 times 4, which is 12, plus 4 times 5, which is 20, plus 5 times 6, which is 30. Of course, after we're done with that, we just add everything up. So this is 50 plus 18, which is 68. So that should be the first answer there. And let's see, what did we do wrong? So that 12, 20, 30. That's 50. Oh, yeah. That, no, that's actually right. So don't see what we did there. So let's investigate. So 2 times 3 is 6. 4 times 3 is 12. 4 times 5 is 20. And 5 times 6 is 30. And if we add that up, 50 plus 12 is 62. 62 plus 6 is 68. So don't know what happened there. So we need to look a little further. All right, so I think the number here is correct. So I'm thinking what I may have to do is just put this in a matrix. So let's see if it'll allow me to do that. So let's see if we do it like this. Okay, yeah. So for this particular example here, it really does come out to be a scalar, but it wants it in matrix form. So we have to write it like that. All right, so let us go ahead and reverse this and now do B times A. All right, so now when we need to multiply matrix B by matrix A, we know we're going to have a different outcome because, of course, the dimensions will be different. So now we have a 4-by-1 matrix being multiplied by a 1-by-4. And since the inner dimensions match, we know that the outer dimensions tell us what the resulting matrix will be. So we're going to have a 4-by-4 square matrix here. And so each number that we multiply together here is going to be a particular location here. So 3 times 2 is going to be 6. 3 times 3 is going to be 9. 3 times 4 is going to be 12. 3 times 5 is going to be 15. And of course, we'll do this for the other two rows as well. So 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And then 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. And 5 times 5 is 25. And then lastly, we know that 6 times 2 is 12. 6 times 3, 18. 6 times 4, 24. And 6 times 5 is 30. And that is what our resulting matrix B times A should look like. And let's come here, tell it to do 4 by 4. And then we'll just enter in the numbers here. So 6, 9, 12, 15, 8, 12, 16, 20, 10, 15, 20, and 25. And then 12, 18, 24, 30. And let's check to see. All right, good. And so now that concludes the second part of matrix operations. So I have one more video to close out the series, and we'll do the last 2 questions.